So Edelkal's SAM model of the nucleus of an atom is demonstrated here with little magnets. If you're familiar with it, this 5, 1, 2, 3, 4, 5, 6 pairing of a flower is a floret, and it's just paired with another one, and then you get a carbon nucleus, which is pretty cool. The SAM model is awesome, great way to understand the nucleus of atoms, but I've always wondered, in this model using magnets, where are the poles? Well, this is what I did last night. I took some paint and I took my magnetic field viewer and I just carefully found where the different poles are, and I did some rough painting. That's what I came up with. It's pretty rough. I actually did it twice with two different kind of paints. The first one was really rough, and this one I had just painted by hand. But now you can see where the poles line up within the nuclear structure. Now, granted, this is magnets, and the nuclear structure, as far as we know, is electric and not magnetic. But, you know, we've got to start somewhere. But there it is. That's how the poles line up. And what's interesting is when you break this out, let me show you this. I thought this was very illustrative, because Ito's whole idea is that different parts of the atom have areas that can accept a new proton and others that can't, that are fully formed. Well, if you see this, you can see that the poles line up in the same way that they line up like that. See, that's easily understandable. North, south, north, south, north, south, and here it's just north, south, north, south, north, south in a circle. All right. So what does that guy look like when you drop him in? Well, you can see that there are parts of it. This area right here is not as strong as some of the side areas. Okay. And you can see why now, because there's a better north-south pole connection here than there is here. Well, actually, I just lost it. Okay, it's right there. That's the weak spot. That's the one that wants to come up, and it wants to stay joined right in here. So it makes sense, and would have to check the SAM model, that when a new one comes in, it would want to fit right in there. And it does. And it did just that. That's the weak side. That's the weak side. And there it goes. It's going in on that weak side. That's where it can accept them the best. The strong side, it will accept them from the strong side, but with a little bit more, yeah, it's a little bit harder. See, it's pushing away.